Hello, my name is Cliff Cummings. I am the VP of Training at Paradigm Works and founder of Sunbridge Design. On behalf of myself and my expert verification co-authors, Heath Chambers from HMC Design Verification and Mark Glasser of Elastics.Cloud, we welcome you to this presentation entitled The Untapped Power of UVM Resources and Why Engineers Should Use the UVM Resource DB API. Let's get started. The paper has more content and better details than we have time to share in a 25-minute presentation. In this presentation, we will share the best content from the paper, but please read the paper for more information and more detailed explanations. To understand why resources were added to UVM, one needs to understand how configuration information was stored in OVM. OVM had three setconfig commands. Each setconfig int command was used to store integer information on one or more components. This setconfig int command used a wildcard string to store the value 2 in a count variable in every component of the test bench. This setconfig string command used an agent wildcard string to store the string value st in an s variable in all of the agent and agent subcomponents of the test bench. And this setconfig object command used an agent2 wildcard string to store the obj object handle in the w variable in the agent2 and all of the agent2 subcomponents of the test bench. This OVM storage mechanism was very inefficient since it repeatedly stored common configuration information into multiple components. And the OVM setconfig commands could only store ints, strings, and OVM object handle types. UVM removed much of the OVM inefficiency by adding a central pool of UVM resources. The UVM resource pool allowed any type to be stored. And since storage was in a central resource pool, information was not directly stored into the test bench components. Primary access to the resources was done using the UVM Resource DB API, while a secondary API called the UVM Config DB was added to allow backward compatibility with existing setconfig commands and was never intended to be actively used by UVM verification engineers. The central resource database could be accessed by the two APIs mentioned on the previous slide, UVM Resource DB and UVM Config DB. The resource database is a central location to store and retrieve type-specific information. The information could be stored and retrieved at any time during the simulation, and all UVM Resource DB and UVM Config DB methods are static, so the methods must be called using the double colon operator. The UVM Config DB class extends from the UVM Resource DB class, and is just layered on top of existing UVM Resource DB methods. The UVM Resource DB has a large number of built-in methods where the most commonly used methods are set, read by name, and read by type, while the UVM Config DB has a smaller set of built-in methods where get and set are the most commonly used methods. The other methods are rarely needed, so they are not discussed in this presentation. So now for the bad news. We estimate that as of DVCon 2023, more than 90% of UVM verification engineers are using the wrong API. Early UVM books and papers all use the wrong API, the UVM Config DB API, and everybody just followed these bad examples. The UVM Resource DB API is powerful and can be used with components, sequences, transactions, and modules, and is simple to use. The UVM Config DB API can only be used with components and requires an overly complex context int name matching mechanism that frequently confuses UVM users. If you use the UVM Config DB API, you frequently have to use p-sequencer gymnastics to pass test configuration information through a sequencer into a sequence. Let's take a quick look at the UVM Resource DB API and the UVM Config DB API set commands. Both commands include a parameter to indicate the type to be stored, a field name string to indicate where the resource is stored in a name table, and the value to be stored. This is mostly what we care about: the type that is stored, where it is stored, and what value is stored. The first argument of the UVMDB set command is the resource scope, which is a somewhat misleading name since this is just a simple matching string that does not have to correspond to an actual component scope. Similarly, the first arguments of the UVM config.db set command are a context class handle, which must be a valid handle to a component, and an inst name string. UVM must convert the handle and string into a matching string, which must be a string to a valid component path. So the first arguments or argument pair is really just a string, which must be matched during get and read operations. UVM resource DB commands also include a final optional accessor argument, which can be used for optional debug tracing. For modules, the accessor should be null, which is the default, while for classes, the accessor should be the this handle. To retrieve the value from a stored resource, we use the UVM resource DB read by name or the UVM config DB get commands. We generally need to declare a variable of the correct type to hold the retrieved value, and that type should match the type parameter of the retrieving commands. The API retrieval commands include a field name string argument to indicate the location in the name table where the resource was stored. The resource commands then list the declared variables which will hold the retrieved value. This again is mostly what we care about: the type being retrieved, where it is retrieved from, and where it will be stored once retrieved. The first argument of the resource DB read by name command is a string that must wildcard match the scope string that was stored with the resource. Similarly, the first arguments of the UVM config DB get command are a context class handle, which must be a valid handle to a component, and an inst name string that UVM must convert into a matching string, which again must be a string to a valid component path. So just like the set commands, the first argument or argument pair is really just a string, which must be matched during these get and read operations. And UVM resource DB commands also include a final optional accessor argument, which can be used for optional debug tracing. UVM resources are maintained in a singleton UVM resource pool, which declares two associative arrays. The first associative array is a name table that is indexed by string values and holds handles that point to UVM queues of UVM resource-based type handles. The second associative array is a type table that is indexed by UVM resource-based type handles and also holds handles that point to UVM queues of UVM resource-based class handles. Initially, the tables are both empty. Each UVM resource DB command adds a new entry into both tables or pushes a new handle onto an existing queue. The queues do not exist until a new entry is added to the tables. Each table entry points to a UVM queue of UVM resource-based type handles, and the queues allow test benches to have multiple queued entries in the same name and same type. Each UVM resource database set command creates a typed resource as shown on the bottom of this slide. Each UVM resource has three fields: a type field that matches the type of the resource, a scope or regular expression field that can include wildcard characters, and a value that is stored in the resource. Each UVM resource DB set command will create two table entries. First, the typed resource handle will be stored in a UVM queue, and the queue handle will be stored at the field name string location in the name table. Second, the typed resource handle will be stored in another UVM queue, and the queue handle will be stored at the type location in the type table. This means each new resource handle is stored in two locations, in two different queues. Each queue is of type UVM resource base, and the typed resources are type parameterized derivatives of the UVM resource base class, so each handle is upcast to the queues of the base class type. Each UVM config DB set command also creates a typed resource. The resource type is again stored in the type field. The context argument must either be null or a valid component handle. The inst name must be a string, and the newly stored scope string must be a valid component path string. UVM uses a set of rules to combine the context and inst name arguments into a new valid scope string. And finally, the value is stored into the value field of the resource. Each UVM config DB set command also creates two table entries. First, the typed resource handle will be stored in a UVM queue, and the queue handle will be stored at the field name string location in the name table. Second, the typed resource handle will be stored in another UVM queue, and the queue handle will be stored at the type location in the type table. Now let's look at a few examples of UVM resource DB set commands and how they work. The first command is going to store a virtual.interface. This command creates a UVM resource of type virtual.interface. The virtual.interface type is stored in the resource. Star agent star is stored as the scope regular expression string, and the DIF handle is stored as the resource value. The scope is just a wildcard string that must be matched when retrieving the resource, and it does not have to match an actual component scope string. This resource will be stored in the VIF string location of the name table. UVM first checks to see if there is already a VIF string entry. And since there is no VIF string entry, UVM creates a UVM queue of type UVM resource base and stores the queue handle in the name table at the VIF string location. UVM then pushes the virtual.interface typed UVM resource onto the queue. Since this typed UVM resource is a derivative of the UVM resource base type, this is a valid upcast operation. As we have already mentioned, each UVM resource DB set command creates two table entries. The first entry into the name table was shown on the previous slide. The second entry will be placed in the type table. UVM checks to see if there is already a virtual.interface type entry in the type table, and there is not, so UVM creates a UVM queue of type UVM resource base and stores the queue handle in the type table at the virtual.interface type location. UVM then pushes the virtual.interface type UVM resource onto the queue. Since this type UVM resource is a derivative of the UVM resource base type, this too is a valid upcast operation. An additional environment config resource was created and stored in both the name and type tables. Now let's use the UVM resource DB set command to create an agent config type UVM resource. The resource will store the agent config type, the star agent1 scope regular expression, and the config1 handle. This resource will be stored at the config string location in the name table, which will create a new UVM queue, and the agent config typed resource handle will be pushed onto the queue. This same resource will be stored at the agent config type location in the type table, which will create another new UVM queue, and the agent config typed resource handle will be pushed onto that queue. Now let's use the UVM resource DB set command to create a second agent config typed UVM resource. The resource will store the agent config type, the star agent2 scope regular expression, and the config2 agent handle. Note that the second agent config typed UVM resource has a slightly different scope regular expression string and stores a different config handle. This new resource will also be stored at the pre-existing config string location in the name table. And since there is already a config string name table entry, the new agent config typed resource handle will be pushed onto the existing queue. This new resource will also be stored at the pre-existing agent config type location in the type table. And since there is already an agent config type table entry, the new agent config typed resource handle will be pushed onto the existing type table queue. Now we see that 4 more resources have been created and stored to various locations in the name and type tables. Now let's use the UVM resource DB set command to create an int-typed UVM resource with an unusual scope argument. This resource will store the int type, the lcount : scope regular expression, and the integer value 10. This resource will be stored at the lcount string location in the name table, which will create a new UVM queue, and the int-typed resource handle will be pushed onto the queue. This same resource will be stored at the int-type location in the type table, which will push the int-typed resource handle onto the existing int-type queue. Note that in this example, the int-type queue in the type table is now 3 deep. But what makes this UVM resource DB set command interesting is that the scope regular expression is not required to match any existing component string path. This means that items, such as transactions and sequences, can now directly access values stored in the resource database. This is a powerful capability. In the example created over the past few slides, 9 resources have been created, and each resource handle has been pushed onto both a name table queue and a type table queue. Using the UVM resource DB, these resources can be retrieved by name or by type. The UVM resource DB read by name command is used to retrieve a stored value from the name table. The UVM getFullName method will return the full path string to the agent that is issuing this command. This will be used as the match string. This UVM resource DB command verifies that it can retrieve a value from the name table stored at the string location VIF. Next, UVM verifies that the resource types match. And finally, UVM verifies that the *agent* wildcard matches the full path name retrieved by the getFullName method. In this example, the agent declared a virtual.interface handle named VIF. The retrieved DIF handle is then assigned to the declared VIF handle. In this final read by name example, the UVM resource DB command includes a match string called lcount : often referred to as a pseudoscope since it does not match an actual component scope. UVM verifies that there is a name table entry called lcount, then verifies that the resource types match. And finally, UVM verifies that the lcount : wildcard matches the match string in the UVM resource DB command. In this example, the sequence declared an int variable named count. The retrieved integer value 10 is then assigned to the declared count variable. When it comes to set commands, the UVM resource DB API can create all of these resources. The UVM resource DB API stores handles in both the name table and in the type table queues. On the other hand, the UVM config DB API can only create resources that have valid component scopes, but cannot create a resource with a pseudoscope that does not correspond to an actual component handle. The UVM config DB API does, however, store resource handles in both the name table and the type table queues, but would not allow storage of resources that have non-component pseudoscopes. When it comes to read by name and read by type commands, the UVM resource DB API can retrieve resources accessing name table entries using read by name commands to retrieve resource values, and can retrieve the same resources accessing the type table entries using read by type commands. The UVM config DB API cannot retrieve resources using pseudoscope handles, and the UVM config DB API can only retrieve resources accessing name table entries, but cannot retrieve resources accessing type table entries, even though they are there. As noted, even though there might be a pseudocode scope entry in the name table, the UVM config DB get command cannot access it. Guideline: use the simpler and more powerful UVM resource DB API and quit using the UVM config DB API. So how did we get this messy UVM config DB API? Why does it even exist? OVM had set config commands that only worked with components and could only store ints, strings, and object handles. And the commands inefficiently propagated the same information on multiple components in the test bench. UVM removed per component storage by adding resources and a database for the resources. UVM developers had a goal to store all information in the database and did not want to support the older OVM set config storage model along with the new UVM resources. The goal was to create a much more efficient storage mechanism. So the goal was to make the UVM version of the set config commands work with the new and more efficient UVM resources. The UVM config DB base class is an extension of the UVM resource DB base class, and the UVM config DB API added restrictions to allow it to only work with components, which was a requirement of the old set config commands. The UVM config DB was never intended to be a primary user API. Unfortunately, the first UVM books and examples all showed UVM config DB usage and steered us all in the wrong direction. More than 90% of UVM verification engineers have been using the wrong API for more than 10 years, including both Cliff and Heath, until we worked on a very large verification project with Mark Glasser. To summarize the set config, UVM config DB, and UVM resource DB capabilities, OVM used set config commands but did not have access to a resource database. UVM should not use set config commands but has access to UVM config DB and UVM resource DB APIs. OVM and UVM can store int, string, and object data types, but OVM cannot store any data type while UVM can. Both OVM and UVM can use glob regular expressions for wildcards, but only the UVM resource database API can use the more expressive POSIX regular expressions. OVM inefficiently distributes information across multiple components, but UVM removes this inefficiency. Most of the rest of this table does not apply to OVM. UVM uses a common and efficient resource database. The UVM config DB API requires a complex component handle and string scoping mechanism, while the UVM resource DB API does not. The UVM config DB does not allow simple string scoping, while the UVM resource DB does. The UVM config DB and UVM resource DB APIs both can store to and retrieve information from the resource name table, but only the UVM resource DB can retrieve information from the resource type table. OVM and UVM can store and retrieve information that is tied to components. The UVM config DB cannot store and retrieve information into sequences, while the UVM resource DB can store and retrieve information with sequences directly. The UVM config DB cannot store and retrieve information into modules, while the UVM resource DB can store and retrieve information in modules. So in conclusion, quit using the old OVM style set config, get config commands. Quit using the UVM config DB API. It has a needlessly complicated context handle, inst name, string scoping requirements, and lacks powerful features that simplify UVM test bench development. The good news is that if you have UVM config DB commands in your current UVM test bench, there is no need to remove them. Use the UVM resource DB API. it has a much easier scoping requirements. And the UVM Resource DB API simplifies the implementation of advanced UVM test bench techniques, including the creation of virtual sequences. Thank you to everyone for attending this presentation.